Welcome to The Explainer. You know that jar of honey sitting in your pantry? Well, today we're going to look past just how sweet it is and really unpack the fascinating science hidden inside.
All right, let's just jump right in. Have you ever, drizzled honey on your toast or in your tea and just kind of watched it flow? Ever wondered why it's so thick and sticky? It's something we all know, but the science behind it? Well, that's where things get really interesting.
So let's start with the stuff you can actually feel, right? The most obvious things. And that all comes down to two key physical properties: viscosity and density.
And what's so cool about this is how simple the rule really is. Viscosity, that's just a fancy word for thickness. It's all about how much water is in the honey. Think of it like this: the less water, the thicker the honey. The more water, the runnier it gets. It's a perfect inverse relationship.
And all that thickness, well, it adds up to some serious weight. Honey is incredibly dense. With a specific gravity of about 1.4, it's nearly 1.5 times heavier than water. That's why when you pick up a full jar of honey, you can really feel that heft, right?
Okay, but honey's magic isn't just about how it feels in the jar, it's actually interacting with the air around it, all the time. And it does this thanks to a really powerful property called hygroscopy.
So, what on earth is hygroscopy? Put simply, honey is basically a moisture magnet. It has this amazing chemical ability to literally pull water molecules right out of the air and hold on to them.
And here's how that works in the real world. If you leave a jar of honey open and the air is even a little bit humid, say over 60%, that honey will literally start drinking the moisture from the air. That's exactly why you've got to keep that lid on tight. It's your honey's best friend, for sure. All right, so we've talked about how honey feels and how it acts. Now, let's switch gears and talk about how it looks, because its color and even the way it plays with light gives every single type of honey its own unique signature.
Think about it. Honey comes in this incredible range of colors, right? From almost perfectly clear to this deep dark brown. And it's not random at all. The color all depends on what flowers the bees were visiting, the age of the wax combs back in the hive, and even how you store the honey.
Okay, now here's a super fascinating science fact for you. The sugars in honey have this really specific property. It's called optical rotation. Basically, if you shine a special kind of polarized light through pure, natural honey, it will always bend that light to the left. It's actually one of the ways scientists can tell if honey is the real deal or not. How cool is that?
Okay, let's talk about the big one. The one thing that confuses pretty much everyone who loves honey: crystallization. What is actually going on when your beautiful liquid honey turns into a solid block?
You know the feeling. You go to the pantry, you grab the honey, and ugh, it's thick, it's grainy, it's solid, and that first thought that pops into your head is, oh no, has my honey gone bad? Can I even eat this anymore? Let me just put your mind at ease. The answer is a big, fat no. It has not gone bad. In fact, far from being a bad thing, crystallization is actually a sign that you've got real natural honey. So, why does it do that? Well, the science behind it is that honey is what's called a supersaturated solution. That sounds complicated, but all it really means is that there is way more sugar packed into that little bit of water than the water can technically hold on to forever. It's basically an unstable but very, very delicious situation.
So over time, all that extra sugar just naturally wants to turn back into a solid. And the main thing that kicks this off? Temperature. As soon as you store honey below about 14 degrees Celsius, that's 57 Fahrenheit, the glucose starts to separate out from the water, and boom, you get those crystals. That's why you see it happen way more in the fall and winter when your kitchen is a bit cooler.
Okay, to wrap things up, let's touch on just a couple more of honey's hidden properties. These really show you just how complex this stuff is. So we all know honey lasts forever, right? Well, it's not totally invincible. Remember that moisture magnet property, hygroscopy? If honey sucks up too much water from the air, it can actually start to ferment. And for a final little surprise, honey conducts electricity. Yep, and how well it conducts is linked to its mineral content, which gives experts another clever way to check its quality and even figure out where it came from.
So, after all that, what do you think? Is honey just a simple, sweet food, or is it an absolute masterpiece of natural chemistry? From how thick it is, to its ability to pull water right out of the air, to the way it completely transforms with temperature, it's so much more than just sugar. It's a masterpiece, perfectly engineered by bees.